Aloha and welcome. In this lesson, we're going to be going over some additional practice of engineering examples. There are two in the book. I'm going to go over the first one. I'll let you work on the second one. It will be a very good exercise in nested loops. So without further ado, this time I'm going to share with you my my browser instead of VS Code, which we usually do. So let's go ahead and share the screen here. Let's find the example. Here we go. All right. So we're going through an engineering example here at the beginning. And if you're like me, you know nothing about physics or electrical engineering or anything like that. So we're just going to read over what it says here. A list can be useful in solving various engineering problems. One problem is computing the voltage drop across a series of resistors. If the total voltage across the resistors is V, then the current through the resistors will be I equals V divided by R, where R is the sum of the resistances. So let's think about that. I is going to be the current, and it's going to be equal to the voltage divided by the sum of the different resistances. Okay, got it. So the voltage drop across Vx across resistor X is then Vx equals I times Rx. So in looking at that, V of X, so for resistor X, it's going to be essentially the voltage is going to be equal to the current times the resistor, that specific resistor. So now that we know that, we kind of have an idea of what the functions or the mathematical problems will look like there. So let's go ahead and look at this. It says, calculate voltage drops across series of resistors. The following program uses a list to store a user-entered set of resistance values and computes I. Modify the program to compute the voltage drop across each resistor. Store each in another list, what we'll call voltage underscore drop, and print the results in the following format. So this is going to be what we need to come up with. Our program should do exactly this. And they're giving us the program right here. So we see that the number of resistors is 5. They set up a list for us of resistors, a set for voltage drop here. We have print the number of resistors. Print X number of resistors in the series. That's the first line. And this program calculates the voltage drop across this. So that's what you see up here. Then we have the input voltage. And this is what they're going to be getting from the input. We have our input values down here, though. That's how we're going to feed that into here. Then we're printing out the input voltage, which, yep. So, okay, so yeah, so it's going to ask us for the voltage. We're going to put in 12, and then it'll print below it the input, input voltage applied to the circuit. We put that in. Then we go down and we say input ohm of the number of resistors, which is 5 resistors. So that's where we get this line. And then we're going to loop through those values. And each time we're going to be, we're going to say res equals the, we're going to ask for the number. So that's where we get this little part. We type in the 3.3, I guess. Then it'll, then it'll append that to res, which is defined, oh wait, hold on. So it takes resistors and it appends the value at res, which is what we just pulled in there. Then it's converted to a float. So that's how we're building up the resistors list. So then we get down to the next part, and that's going to be where we calculate the current. So we've got current equals the input voltage, which the user inputs here. And we divide that by, remember, it's the sum of all the resistors. So we have that built-in formula called sum, and it's going to add up everything in resistors that we made up here in this list. So that gives us the calculate the current. So we've got to calculate the voltage drop over each resistor. So voltage drop is going to be this formula right here. Or wait, no. The voltage drop is going to be this here. Voltage equals I, which is the current, times R. So for Okay, so ooh, this looks like a list comprehension, because what we're going to do is for each of those resistors, we're going to multiply the current by that that amount of resistance. So that looks like a list comprehension to me. So let's go ahead and calculate the voltage drop. So it's going to be voltage. The voltage drop is going to be the current times the thing in each position. So let's go ahead and set that up over here. So we'll call it voltage drop because that's what they gave us as the list. And we will, well, we're going to do a list comprehension. So let's go ahead and start our brackets right there. Give us some space. And how do we do that? We have expression first. So the expression is going to be what we're going to store for that. So that's really going to be the formula itself. So we're going to have current, which we just calculated right here. So we'll say current times the resistor at each place. So let's call the resistance of this one res for now. And then we have our for statement because this is our list comprehension. So for res in, what's the thing? Resistors. So this is going to take each value in resistors, multiply it by current, and it's going to put it in the place for the voltage drop. So this should give us a list of the voltage drops. Then it wants us to print the voltage drop per resistor. So this will be a handy dandy little for loop. So we can go ahead and say for drop in voltage drop. Then we will come and print it, but we're going to have to print it. Oops, hold on. I see something that I need to do first. So we need to print out this text here. So let's go ahead and cheat and just copy it. So we'll come down here, we'll print out that. So that'll give us that print. So now what we're doing is we're going to print out the one with the, yeah, the one in the open parentheses, or the closing parentheses. And then we're going to take our data, the 3.0 is going to be our data, then we'll put in the V after it. But I just saw something. We need to be able to generate that 1, 2, 3, 4, and 5. So if you remember, we can use enumerate on iterable thingies. And voltage drop is an iterable thingy. It is a list. So we will use enumerate, and that will give us the index. And it's the index we're going to need up there. So we're going to print. We're going to do a print here, and we're going to print out, let's make it a F string. And the first thing we're going to have is index. And we're going to put that little close parentheses there. And we're going to put a space in there. Then we're going to have our drop value right there. Then we're going to do a space and then V. And that should do it, I believe. The one downside is coding like this. If you're coding in an environment, it'll, you've got color-coded things that hint at, oh, you've got a problem here. So if I forget to close a single quote or something like that, it'll tell me, it'll show me a little, a little color here or there. So I don't have that here. So I'm hoping this is correct and I've got everything in the right place. So let's go down here and click on run. And hopefully we don't flag an error. We did not get an error. Let's see, we got 12, the input. So I'm looking to match it up to here. So 3.3555, all that stuff. Then we have the voltage drop per resistor is, then they have 3.0 volts. We have a big number. So that tells us we have a little problem here. What is our little problem? We want to round everything off. So digging back into our string formatting memories here, we can go in here and we can take the drop, we can put a colon here, and then we can specify, I think it's, so we only have one number of precision here. So we're going to do a 0.1 F, if I remember correctly. And then if we hit run again, we go down here. Yes, so we get the value rounded to one position. So we should get 3.0, 1.4, 3.0, 1.4, then 1.8, 3.7, and 2.0, 1.8, 3.7, 2.0. Yep, so we did it. So that is how you solve this problem. So that is the end of this one. And then the next one is going to be matrix multiplication of 4x2 and 2x3 matrices. Yes, this is exciting stuff. If you remember matrix multiplication from school, from mathematics, I won't go digging into this, but you'll be essentially modifying this program here, which is going to give you what the multiplied matrix looks like. It tells you to play around with changing the size and value of the matrices and things like that. Remember, when you go in here and you change your columns or whatever, you're going to have to also change your resultant set and everything and the way that's set up. So have fun. This is a really good practice in multi-level nested for loops. So you've got 3 levels here. So that's going to be a lot of fun to play with. I say that very sarcastically, and enjoy. So if you do have any questions, feel free, reach out. That's a little bit more involved than I wanted to go into right here. So if you do have questions, send me an email, reach out. We can set up a Zoom chat to go over things. But this is the purpose of this whole thing is just to give you an idea of how you would see this stuff in actual practice out in the wild. So what are some use cases of list comprehensions, things like that. And this is an example here. So I have to say that in 26 years of professional programming, I have not yet had to do anything like matrix multiplication. Maybe your job, you'll end up doing it. Me specifically, no, I have not. I have had to do other things like, mathematical formulas where you're going to be applying the same thing to each member of a list. So this is something that definitely is helpful. So yeah, I'd focus more on the first problem. The second one, if you want to do that, enjoy it. It will really give you some practice in going through nested loops. So enjoy, reach out if you need, and I'll see you in the next lesson. Aloha.